Hello, Math 1 students. Mrs. Robinson here to work Practice Benchmark Chapter 11 with you. Let's get started. Now, Chapter 11 was all about proving theorems about lines and angles, parallel lines, cut by transversal. Just so you know, in the back of your workbook, if you wanted to mark it as a reference, there is a section called Postulates and Theorems, and it will have all the postulates and theorems all there together. So that's a good spot to go for reference. We're going to go ahead and state the theorem or postulate that justifies each statement. So let's go ahead and mark it off so we can see what we're looking at. If angle 2, I'm going to mark this. Oh, I need to be something else besides white. If angle 2 is congruent to angle 4, then P is parallel to Q. So it helps to mark when you have two parallel lines going this way, and then these lines are not marked parallel. These lines are marked parallel. That little triangle means parallel. But if I can prove something, then I can say P is parallel to Q. So let's go ahead and mark, let me undo that. Let's go ahead and mark P, there's P, and Q so I can see what I'm dealing with here when I've got four lines. Sometimes it's hard to tell where the lines are parallel, where the transversal is. So there's the two lines I'm talking about, P and Q. And then let's put in blue this line just so we can see the angles we're talking about. So I have these two red lines and then this blue because I'm dealing with angle 2 and 4. So if angle 2 and 4 are congruent, you can see that these would be on the inside of the red lines, P and Q, and they're alternating. So they would be alternating interior angles. So normally we say if two lines are cut by transversal and they're parallel, so two parallel lines cut by transversal, then alternate interior angles are congruent. This is the opposite. It says if these alternate interior angles are congruent, then the lines are parallel. So this would actually be the converse of the alternate interior angle theorem. And I'm just going to shorthand it because it's hard to write. All right, so mark it out. It makes it easier to see. Okay, number 2, we have angle 3 and angle 8. So I can see, and then we're going to talk about P and Q again. So once again, I'm going to mark off P and Q so I can see what lines I'm dealing with. There's P, there's Q. And the line, the transversal, that would be of importance would be this one right here. All right. So looking at those lines, ignoring this one now, if we know angle 3 is congruent to angle 8, which is what I'm giving, then P must be parallel to Q. Now look at what angle 3 and angle 8 are. They're in the same position on the same side of these lines, of these two lines we're trying to prove that are parallel. These will be called corresponding angles because they're in the same position on the same side. And we have a corresponding angle theorem. If two parallel lines are cut by transversal, then corresponding angles are congruent. Now, if we have the opposite, we're given that the corresponding angles are congruent, then the lines are parallel. That would be the converse of, I forgot an E on that, the converse of the corresponding angles theorem. Sorry for the messy handwriting. All right, just a little shorthand. That's angles. Corresponding angles. That's supposed to be an angle. Corresponding angles theorem. All right, just a little shorthand. Okay, let's look at number. All right, looking at number 3, angle 6 and angle 8. Okay, so here would be the transversal that would be of importance for those two angles. And these lines are already marked parallel. These are already marked parallel. So instead of the converse, we have the straightforward theorem. Two parallel lines cut by a transversal. Now look at the placement of these. This line and this line is marked parallel already. So these are on the inside of the parallel lines and they're alternating. So these are the alternate interior angles. So this If I have two parallel lines cut by a transversal, alternating interior angles are congruent. This is just the alternating ALT interior angle theorem. All right, and that's all there is to it. Let's look at number 4. We have angle 6 and angle 9. Once again, this would be the transversal involved here. And then these two lines are already marked parallel. So look at this transversal and these two lines. Identify the lines you're working with. We don't care about any of this over here right now. We don't care about line P. So two parallel lines cut by a transversal now. Angle 6 and angle 9 are congruent. So the reason they're congruent is because they're in the same place on the same side of this parallel line and this parallel line. So they're corresponding. They're in the corresponding positions. So this would just be straight up the corresponding angles theorem. Okay, not the converse, just the straightforward theorem. Okay, number 5, name two pairs of each type of angle. We want to name the same side interior and the same side exterior. They literally mean what they say they mean. Okay, so the same side interior, if I'm dealing with these two lines right here, these lines that are marked parallel, okay, and let's isolate what we're looking at first. If this was our transversal, then these two angles are on the same side of the transversal, and then they're on the interior of the parallel lines. So I'm going to say angle 2 and angle 3 are same side interiors. Also, if this was the transversal, on the same side of the line, 7 and 8 are on the same side of this line, and they're on the interior. So I'm going to say angle 7 and angle 8. There's two pairs. Now, I could have also done this. I could have said these two are my lines. Now, they're not marked parallel, but it doesn't matter. We're just identifying same side interior angles. These two are my lines, and let's do this as my transversal. Okay, same side interiors for these two lines and this transversal, 2 and 6. They're on the interior on the same side. So angle 2 and angle 6. Oops, that's supposed to say angle 6. These are same side of this transversal, and then they're on the interior of these two lines. Now 3 and another one could have worked, but we don't have that angle marked. Or this angle and this angle would be same side interiors for these red lines. All right. So any of these will work. Now, same side interior angles are not congruent. The postulate, I just looked, guys, in the book made a theorem 11 in the back of your book in the postulate section says if two lines and a transversal form same side interior angles that are congruent, they're actually not congruent. They're supplementary. They add to be 180. It's the only one that's not the congruent theorem. Okay. They're supplementary. Now, same side exteriors, we don't talk about a whole lot, but let's say I have these two parallel lines, or they don't even have to be parallel. Let's say I have these two lines and this is a transversal. Same side exterior literally means what it sounds like. Angle 1 and angle 5 are on the same side of this transversal, and they're on the exteriors of the red lines. So same side exterior would be angle 1 and angle 5. Let's see. If this was the transversal, I don't have exterior angles. I have corresponding angles, so that wouldn't work. So let's go ahead and see if I can find any more same side exteriors. Let's switch to these lines. Let's have this line and this line be my two lines, and then let's have this line be my transversal. Okay. Exterior angles would be on the outside of the lines, and I have this angle but not that angle. Let's look over here. I don't have either of those named, so that's not going to give me anything. Let's go ahead and make that be our transversal. If this is our transversal, let's see what I have here. I have this exterior angle and this exterior angle, and they are on the same side. So angle 4 and angle 9. same side exteriors. Now 5 and this could be same side exteriors, but that one's not marked. Same side exteriors are also going to be supplementary, and the reason is if you look at same side interiors, like 7 and 8 are same side interiors and they are supplementary. And look, these are vertical angles. These are vertical angles. So if this equals this and this equals this, these will also have to be supplementary. So it's going to work out to be that way. But same side exteriors, we don't necessarily have a theorem on it, but that's what those would be. All right, so many little rules you could make up out of two parallel lines and a transversal. Okay, if the measure of angle 3, here let's mark it, measure of angle 3 is 20. What is the measure of angle 6? This angle right here, okay? Well, I have two parallel lines because they're marked parallel, and I have a transversal. What are these angles? They're alternating and they're on the exteriors. So know your theorems. If you have two parallel lines cut by a transversal, alternating exteriors are congruent. So the measure of angle 6 is also 20, and you're done. So simple, right? All right, let's look at problems 8 through 10. Angle 1, 2, and 3 are interior angles of a triangle. Angle 4 is an exterior angle with remote interior angles 2 and 3. You need to make a drawing here. So let's go ahead and make a drawing. I don't have a triangle. I'm going to have to just go ahead and make a triangle. So here's a triangle. Okay. It looks kind of equilateral, but it's not necessarily. And then we want an exterior angle. So, I mean, any of these could be exteriors. Let's draw a triangle according to what this says. There's different ways to draw this. 1, 2, and 3 are interior angles. 4 is an exterior angle, so let's make this be our exterior angle right here, angle 4. And its remote interiors are 2 and 3. So if it's remote, if this is 4, remote interiors will be angle 2 and angle 3. This will have to be angle 1. If this is an exterior, remote interiors mean the two opposite angles, okay? Now let's just be reminded of our little theorem. The exterior angle is equal to the sum of the two remote interiors. And just remember that when we're working with these. That's easy to see because 4 and 1, if you look at 4 plus 1, these two angles will have to equal 180 because they're a straight line. Now 1 plus 2 and 3, 2 plus 3, these two plus 1 will have to equal 180 because they add up to be a triangle. All the interior angles of a triangle add up to be 180. So angle 1 plus angle 2 plus angle 3 has to be 180. Well, look at this. If 1 plus angle 4 is 180 and 1 plus angle 2 and 3 is 180, then we say 4 has to equal 2 plus 3. So the exterior has to equal the sum of the two remote interiors, all right? So we're going to use that here, and let's do a couple different scenarios. Number 8, let's go ahead and look at this. Angle 4 is 110, and then angle 2 is 70. Find angle 1 and 3. Okay, we know 110 is equal to the sum of 2 plus 3, or 110, or excuse me, I could do 110 plus 1 to equal 180. Lots of different ways to solve this. So let's go 110 plus 1. We know 110 plus angle 1 has to be 180. So I'm going to subtract 110 from both sides, and I'm going to get I should write measure. The measure of angle 1 is going to be 180 minus 110, so 70. So if that's 110, this has to be 70. Now I can figure out angle 3 easy because these add up to be 180. 70 plus 70 is 140. And if these add up to be 180 and this is 140 together, that only leaves 40 left for here. So this has to be 40. So measure of angle 1 is 70 degrees and measure of angle 3 it will be 40 degrees. All right, on to number 2 or number 9. Okay, we got the measure of angle 3 is 40, so this one is 40. The measure of angle 2 is 65 degrees. We want to find 1 and 4 this time. Okay, so we know 4 is equal to 2 plus 3. We can find 4 right away. We can find 1 right away because we know all these angles add up to be 180. So lots of ways to do it. So we're going to go measure of angle 4 will equal measure of angle 2 plus measure of angle 3. So that will be 40 plus 65. Well, 60 plus 40 is 100, plus 5 more will be 105. Measure of angle 4 is 105. I'll put that right here, 105 degrees. Now, these two add up to be 180, and also these add up to be 180. So either way you want to do it. 105 plus 1 has to be 180. 105 plus 1 has to be 180. Now, most of you won't, you could just do this in your head, or you could subtract 105 from both sides if you want to do it this way. And I wrote 1, and I apologize for that. I should be more accurate. I'm just doing it quickly. This should be plus the measure of angle 1, all right? Subtract 105 from both sides, and you're going to get, and I'm writing on my face, measure of angle 1 equals 180 minus 105 is just going to give you 75. So this should be 75, and the measure of angle 1 will be 75 degrees. Okay, on to number 10. Okay, measure of angle 1 is 60 this time. 60 degrees, and angle 3 is 30. So this time we have to find 2 and 4. Okay, I can find 4 easy because this makes up a straight line. So measure of angle 4 plus 60 will be 180. So I'll write that. Measure of angle 4 plus 60 degrees is 180. So I just have to subtract 60 to figure out measure of angle 4 will be 180 minus 60, and most of you can do this quickly in your head. You don't have to do all this writing out. You just go 180 minus 60, and you're going to get 120 is the measure of angle 4. So 120 degrees, measure of angle 4 is 120 degrees. All right, and now we need to find angle 2. Couple ways you could do it. This equals this plus this, or you can do these two together plus this is 180. Let's do it that way. Measure of angle 2 plus these two angles. Let's just add them quickly. 1 and 3 is 60 plus 30 is 90. So measure angle 2 plus 90 has to equal 180. And you guys should see right away, 90 plus 90 is 180. You can subtract 90 for both sides or just do it in your head. Measure of angle 2 should equal 90 degrees. And I should have put the degrees there. So measure of angle 2 should be 90. If this is 60 and that's 30, that has to be 90. It doesn't look like 90, but a 30, 60, 90. Okay, so make sure you draw out a triangle first before you do these problems. Please draw yourself a triangle. Okay, two angles of a triangle have measures 51 and 87. What's the measure of the third angle? This should be super basic compared to that last problem. Okay, 51, 87, the third angle, angle 3 over here, you just go 180. And then you subtract off 51 and subtract off 87. And you should get 42. So the measure of the third angle is 42 degrees. Okay, looking at this, we need to find x and y in this diagram. So once again, we have a 90 here. It's marked. We need to figure out these two. Well, if that's 140, you know this is equal to the sum of this plus this. So that's one way you could do it. Or this plus this is 180. So if this makes a straight line and that's 140, and together it's 180, what's left is 40. 40 is left. You should be able to do that in your head. And if this is 90 and that's 40, then all the angles have to be 180. You're just going to go 180, subtract off 90 for this angle, and then subtract off 40 for that angle, and you should be left with 50 left over. So this should be 50. So angle x should equal 40 degrees. I put x degrees, and y degrees should be 50 degrees. All right, pretty easy. Okay. To find 1 and 2 in this, looks like a quadrilateral, but really what you have is two parallel lines cut by a transversal. Now, there's a couple theorems you could do. Here's your transversal. Let's try that again. Here's your transversal, okay? And then here's your parallel lines. And the transversal on the other side also works, right? For these two parallel lines in red, Okay, they're marked parallel with the arrows. Check the arrows out. Now, if two lines are parallel, these are same side interior angles. And same side interiors are not congruent. It's the only one that's not a congruent theorem. They are supplementary. They add to be 180. However, if that's 90, this also has to be 90 because 90 plus 90 is 180. So they happen to be congruent here. So the measure of angle 1 has to be 90. Now another theorem you could have used if you have two parallel lines and one line is perpendicular to the parallel line, then this will also, that transversal will be perpendicular to the other line. So if the transversal is perpendicular to one line, it's perpendicular to the second line. Same rule, all right? Now looking at angle 2, we can figure this out because all the angles add up, excuse me, the interior angles of a quadrilateral are a 360. That's one way you could do it. And if you have 90 plus 90 plus 80, you just subtract that all from 360. Or you could do two parallel lines, and then this is your transversal. Same side interiors are supplementary. So if they add up to be 180 and that's 80, that leaves 100 left here. So know all your little theorems, lots of ways to do this. And there's your solutions. All right, let's find number 14. All right, find the measures of angle 1 and then angle 2 out here. These are like little puzzles testing your knowledge of what you know about your theorems of parallel lines and triangles and whatnot. Look here, you have a triangle and we need to figure out angle 1. We have this angle, it's 90. I can figure out angle 1 because look, I have vertical angles here. Angle 1's easy, it's 68. Now if I knew this angle, I could figure out angle 2 easy because they're vertical angles. And I can figure out this angle because all the angles of a triangle add up to be 180. So I just go 180 minus 90 minus 68. Let's see, this will be 90, and then 90 minus 68 is going to give me 22. So this will be 22 right here. And if this is 22, then angle 2 is 22. So the measure of angle 2 is 22. And the measure of angle 1 is 68 degrees, and that's degrees. All right, easy enough, just know your theorems. Okay, 15, decide whether the pair of angles labeled, if they're alternate interior, same side interior, that's the ones that are supplementary, corresponding, or alternate exteriors. So let's look. I have two lines, I have a transversal. These are on the same side. Sorry, they're not on the same side. They're on alternating sides of the transversal, but they're on the inside. So they're alternating interior. Alt interior angles. All right. Okay, 16, I've identified all the numbered angles that are congruent to the given angle. So the given angle is the value that you've been given, right? This is our given angle. So first of all, vertical angles are congruent, so I'm going to mark 6. So I know angle 6 is congruent because of vertical angles. That's an F. V-E-R-T. Vertical angles are congruent, okay? And then, let's see, corresponding, here, look, these two lines are marked parallel, and this would be our transversal. So these are corresponding angles. They're in the same place on the same side of our parallel lines. So they're corresponding. So we're going to go angle 4, corresponding. Okay. And then I'm going to mark that. Now, these two angles are alternating interiors. So angle 2 would have to be congruent because of alternate interiors. All right. These two are congruent. And I'll mark that. Anything else? Let's see. These are same side interiors. Same side interiors are the one that is not congruent. It's the supplementary. Not according to the back of your book. They made a mistake. Same side interiors are supplementary. I think that's all you can get out of that. Yeah. Angle 6, angle 4, angle 2. All right. Let's go on to 17. All right. You've got two parallel lines. Here's your parallel lines. I'm going to draw on this one because you've got two transversals, so I don't want to get them. All right, two parallel lines. We need to find angle 1 and angle 2. So here's angle 1 and angle 2. They're on two different transversals. So let's work with one transversal and then the other. Let's work with this transversal. These lines are marked parallel with the arrows. These are same side interiors. That's the one theorem that's not the congruent theorem. Same side interiors are supplementary, meaning they add up to be 180. So I'm going to go 180 minus 50 to get angle 2. And I'm going to get 5, 6, 7, 130. I can do it, guys. I can do it. Apparently, at 6 o'clock at night, I cannot do that. Okay, measure of angle 2 is going to be 130. All right, so now I have this one. Now I need to figure out angle 1. Well, look, now let's go ahead and forget about this parallel or this transversal, and let's look at this transversal right here. Okay, these two lines are parallel. This is a transversal. Alternate interiors are congruent. So angle 1, measure of angle 1 is going to be 95. And you're done. If you know all your theorems, this is going to be a pretty easy test. Okay, find the value of x in number 18. Then find the measure of each labeled angle. So we need to find the measure of these angles. First we have to find x, and we can plug it in and figure out these angles. Now I've got a triangle here, a couple things I could do, but look, this line is marked parallel to this line. Okay. Now since those lines are marked parallel, this angle, let's see, and this could be our transversal right here. Let's mark that in blue so we can see it. Here's our transversal. Sometimes it helps just to highlight that. And then this angle and this angle are corresponding angles. So if two lines are parallel, cut by transversal, corresponding angles are congruent. So I can just do this. 4x minus 12 equals 3x plus 6, and solve for x. A little algebra here. Subtract 3x from both sides. And I'm going to get x minus 12 equals 6. And then add 12 to both sides. And I'm going to get x equals 6 plus 12 is 18. So find the value of x. X equals 18. That's the first part of your answer. And cut myself off. Sorry, guys. Now the second part. Find the measure of each labeled angle. So I need to plug in x into either of these because they're the same. So you just find it once. So plug in x here, and I'm just going to go 3 times 18 plus 6. 3 times 18, 24, 16, minus 2, 4, 6. So this will be 54 plus 6, which is 60. So this angle will be 60, this angle will be 60. So x equals 18, and then the two angles will be 60, comma, semicolon, 60. And there's your solutions. All right, let's go ahead and look at 19. Careful with this. Which lines or segments are parallel? So we have AB and CD. We also have BC and DE. So we need to figure out based on the markings which are parallel. Let's highlight what we're looking at. AB, this is kind of confusing with the drawings, so draw them out and highlight them. I'm looking at CD and AB first. So these two lines, are they parallel? Well, there's the two lines, and then here's my transversal. What do I have here? Let me try that again. Here's my transversal, all right? What do I have marked here that could help me? If these two lines I'm talking about, in order to show that they're parallel, they're not marked parallel, but I want to show that they're parallel. Which lines are parallel? Well, look, angle 40 and angle 40, these are marked. So if these two are the lines and this is my transversal, angle 40 is congruent to angle 40. So these would be corresponding angles with these two parallel lines. Since they are congruent, I can now say AB is parallel to CD. I can say that because I have this, okay? Now let's go ahead and mark our other two lines and highlight them. Okay, so we have BC, which I missed. Let me try that again. BC and DE, and I missed that one. Let's try it. Okay, so there's those two lines. Now let's look at the transversal for those two lines. Here's the transversal right here, okay? Now based on those two lines, this right here is marked congruent to this. So once again, I have two lines and a transversal and corresponding angles congruent. So I can say BC is parallel to DE based on the markings, okay? I can say BC is parallel to DE. So which lines and segments are parallel based on the markings? These two are parallel, and based on these markings, these two are parallel. Now careful on the test. If I had this same problem and those markings were missing from this set of parallel lines, I could not say that they are congruent. You can only say, or excuse me, I could not say that they are parallel. I can only say that two lines are parallel if I have enough information to state so. And I do, because I have corresponding angles. If these markings were gone, I could not say that these two lines are parallel. So careful, careful, careful. All right, let's look at the next one, number 20. Find the value of x that will make AB parallel, or excuse me, A parallel to B. So if I want A to be parallel to B, what do I have here? These are alternating exterior angles. Now, if two lines are parallel, alternating exteriors are congruent. So if these two are congruent, then these two will be parallel. Same theorem all the way through this test, guys. So I need 143 to be equal to 6x plus 17. I need that to be true for these two to be parallel. So I'm going to solve for x, subtract 17, a little algebra here. And I'm going to run out of room. 6x equals, hold on, I'm going to get a little more space here. I tried to scroll up, but it moves this all around, so we'll just do it here. 143 minus 17, what does that give you? Let's see, 126. Now to solve for x, we divide both sides by 6, and I'm going to write my writing over here. Sorry about this. 126 divided by 6, do that on a calculator, I'm going to get 21 equals x. So I've solved for x. So what's the value of x that makes these two parallel? X has to be 21. If that's 21, then these two are congruent. Alternate interiors are congruent. So there's the answer for number 20. Let's go over here and do 21. Clear this off and scroll up. Hold on, let me scroll up. Okay, for what value of x makes A parallel to B? Now this one's tricky because it's got a bunch of stuff here. This could be there to throw you off. I can say, like, if this is 6x, that's also 6x. But look, this angle doesn't touch these parallel lines at all. That's not even useful. So I'm going to highlight my useful information so I can throw out the nonsense. I need A parallel to B. That's what I need. Okay. Now, if this was my transversal, I would need information about these two angles or these two angles right here. And I don't have any of that. I have information about this angle. It doesn't even touch this parallel line. Okay, so I'm going to go with not that transversal. Let's use this transversal right here. And if I could draw it, there we go. That's highlighted in blue so we can see what transversal we're using. And that guy's there, this transversal, and that middle angle is there to just mess with you. All right, this angle here is 3x. And if these lines are going to be parallel, alternate interiors are congruent. This would also have to be 3x. Now, I don't know that. I'm trying to find the value of x that would make this true. But if these two are alternate interiors because they are parallel, if that's 3x, that would have to be 3x. Now, these two right here would be on the line. These two will have to be 180 degrees. They would have to sum to be 180. So if it is true that these are parallel, alternate interiors are congruent, that would have to be 3x. So I'm going to mark this as 3x. Okay. Or similarly, I don't know. I could go alternate exteriors. If this is 12x, then right here would have to also be 12x. That's 3x, this is 12x. These would have to add up to be 180. So what I'm going to do is I'm going to say 12x plus 3x has to be 180 for this to work, because the alternate interiors would have to be congruent and the alternate exteriors would have to be congruent for these two to be parallel. And if that is true, that has to be 12x and that has to be 12x. That has to be 3x, that has to be 3x. This would make a line, it would have to be 180. So this is where I'm going to work it here. This one takes a little bit more thinking. 12x plus 3x is 15x. That equals 180. And then to solve for x, I'm going to divide both sides by 15. And I'm going to get x equals, what's 180 divided by 15? 12. X is 12. So if x were 12, this would work. This would be congruent to this, and these would add up to be 180. All right, and that's how you do that one. A little more thinking. These have to be 180 because that's a line, right? Okay, we're going to really make sure you know this concept. C and D, we want those two to be parallel. So here's my two parallel lines. There's my transversal. I want to know the value of x for which C is parallel to D. So we need to then find angle 1 and angle 2. These are alternate exteriors. If C is going to be parallel to D, alternating exteriors, see they're on the outsides of these parallel lines and their exterior, they're alternating this transversal. Alternate exteriors. If those are going to be congruent, then these lines will be parallel. So I need those to be congruent. We're told measure of angle 1, this one is 90 minus 6x. And then we're told the measure of angle 2 is 100 minus 8x. We need these to be congruent, so we're going to set them equal to each other. A little algebra here, 90 minus 6x has to equal 100 minus 8x. And now we're going to solve for x. Get your x's together. I'm going to go ahead and add 8x to this side so that I have positive x's. So I'm going to add 8x here. And I'm going to have 90, and then that'll give me plus 2x's equals 100. My x's always do that, I don't know why. All right, now to get x by itself, peel that off. So subtract 90 to both sides. And you're going to come up with 2x equals 100 minus 90 will be 10. And then divide by 2. So you're going to come up with x is 5. All right, so determine the value of x for which C is parallel to D. X has to be 5. Okay. If x was 5, I'm going to plug x in here or here, it doesn't matter. Plug it in. 5 times 6 is 30. 90 minus 30 is 60. So this angle will be 60 degrees and this angle will be 60 degrees. So then find the measure of angle 1. The measure of angle 1 has to be 60 and measure of angle 2 has to be 60. They have to be congruent. And you're finished with that one. All right, 23. Find the value of the variables and the measured angles. So if that's x, this is 6x plus 10, this is x plus 2. I don't have any information. I am not given any angle here. But what I do know is all the angles add to be 180. So a little more work here, but you can figure it out. Just set up an equation. This plus this plus this has to be 180, and then solve for x. If you can set up an equation, you can solve for x. X plus 6x plus 10 plus x plus 2, this plus this plus this has to be 180. Now solve for x. Combine your like terms. 1x plus 6x's, that's 7x's, plus one more x, 8x's. So I've got 8x's. Sounds like all of my x's live in Texas. Okay, then 10 plus 2 is 12. And that equals 180. Now go ahead and solve for x. Minus 12 from both sides. And then I'm going to come down here for space. So I'm going to get 8x equals 180 minus 12. What's that? 170, 168. And then divide both sides by 8. And then you're going to get x equals, what is it? 168 divided by 8. 21. X is 21. All right. Find the values of the variables and the measured angles. So my first thing would be x is 21. And then that would be this angle. And then this angle would be 21 times 6. So 21 times 6 is 126 plus 10. So this will be 136. And then 21 plus 2 will be 23. 23, 136, and 21 are all of the measured angles. And there you have it. All right, on to 24 and 25, and then we'll be done. Find the value of each variable. All right, a little more work here with the triangles. So vertical angles are congruent. If that's 37, A has to also be 37. So start out with A is going to be 37 degrees. Easy peasy, 37. Okay, now this makes a straight line right here. So if that's 37, you can figure out that because together they have to be 180. So I'm going to go to figure out C, I'm going to go 180 minus 37, and that's going to give me 143. So right there, C has to be 143. So I'm going to go C is 143. Now if that's 37 and that's 109, I can figure out that because this is a triangle and it adds up to be 180. So to get B, I'm just going to go 180 minus 109 minus 37. Just subtract all that. You can do it on a calculator. You can do it by hand. That's a 0. All right, so if I do 180 minus 37 minus 109, I'm going to get B is 34 degrees right here. And then B is going to be 34. Now, if you're kind of picky and you like it to be in order, write A, then B, then C in the right order, go ahead and change the order. Just make sure you label it for me. All right, on to the last one. Find each missing angle measure. This is the exterior angle is equal to the sum of the two remote interiors. Right back to that. So we're just going to go 48.3 degrees is going to equal angle 2, measure of angle 2, plus this angle, 26.8 degrees. And then to figure out the measure of angle 2, I just subtract 26.8 degrees from both sides. And then I come up with my solution. Measure of angle 2, that was a really weird measure of angle 2 is equal to, if I do 48.3 minus 26.8, I should get 21.5 degrees. And that is the measure of angle 2. Just make sure you know that theorem. Exterior is equal to the sum of the two remote interiors. Otherwise, you have to go, this makes a straight line, find that, and then subtract these two from 180 to get that, but that's more work. So just do it that way. All right, guys, that's the whole practice benchmark. Email me if you have any questions. I'll see you in tutoring. Have a great day.